Hello बच्चों, good morning. Myself Dayalchand Pathak. I welcome you all to my channel Physics Made Easy by DCB. So in class 12th we were discussing our first chapter electric field and charges. In last video we have discussed by using Gauss law what is the electric field due to a solid sphere, uniformly charged solid sphere at its center, at inside the sphere, outside the sphere and on its surface. Now today lecture is very important for you because most of time the question in competitive exam you will get from this lecture only. Today whatever we will discuss, this is very important for the board and as well as competitive exam. Is it clear? So now we will start today. What is topic today? We will start the topic electric field due to ring which is uniformly charged ring at its axial point. Where? At its axial point. This is our task. What is our task? Our task is to find out electric field due to a uniformly charged ring at its axial point. Where? At its axial point. This is our task, to find out the electric field due to a ring at its axial without Gauss, using Gauss law. This derivation is without. All the derivation whatever we will do today, here we have to do general way, means without Gauss law. Because we know Gauss law is applicable only whenever there is symmetry. If there is no symmetry, in that case we can't use Gauss law. Just for dipole, it is not possible to find out the electric field of dipole because total flux will come to zero. Why total flux? Why it is not possible to find out electric field? Because it doesn't show any symmetry. वो कोई भी symmetry नहीं दिखाता है. तो Gauss law is applicable only for symmetry. So here now. So for that, this derivation, first of all we will consider a ring. Suppose this is a ring of radius capital R. This is the radius of the ring. This is its center O. There is a point on its axis line. This is a point P at a distance x where we wish to find out the electric field. So to solve this derivation, first of all we will consider ring. Suppose this is a ring of radius capital R. There is a point P from at distance x from its center. Now this ring is uniformly charged. Suppose we give it charge Q. So charge will distribute on its surface. This charge Q we have given. So the charge will distribute on its surface like this. Is it clear? Now here our task to find out electric field. For that what we will do? We will write, let us consider a ring of charge plus Q and radius capital R and a point P at distance x from center. At distance from center there is a point. All the things we will write here what we have done. Okay, now our task to find out electric field at this point due to this. For that what we will do? Without Gauss law, whenever we will use without Gauss law, for that first of all we will consider a small element of this ring whose length is dl. Let a small element dl of charge dq. Let its charge is dq. How much plus charges are here? dq plus charge is on this ring. So without using Gauss law, if you will find out the electric field due to any body, then for that first of all you will consider a small element dl. Let this is a small element dl whose charge is dq. Now what you will do, you join it, this element, through this point. Clear? You join this point through this एलिमेंट, अरे मान लेंगे थोड़ा सा, दिस इज पॉइंट सोर्स, क्लियर? नाउ suppose this distance from this point is r, how much? R, clear? Now what we will write? Electric field at P due to small element dl, due to small element dl, what will be the electric field? dE equal to 1 upon 4 pi epsilon naught dq upon r square. What is the meaning? That means if you will find out the electric field due to this small element dl, electric field formula E equal to 1 upon 4 pi epsilon q upon r square. Q is how much? dq. Charge of this is dq and its distance is how much? R. So r square. Is it clear? Now this is which type of charge? Plus charge. Due to plus charge, electric field is outward. Due to plus charge, electric field is outward. That means at this point, this field will be like this. Clear? So here we will write away from dl at P. dl से away, दूर. Let this make an angle how much? It make an angle with horizontal how much? Theta. Let DE make an angle theta. Yes or no? Then what we can do? We can divide it into two components. कौन से? DE cos theta. This is the horizontal component. D cos theta is the horizontal, and vertical component is DE sin theta. Everybody know, if any vector quantity will make an angle, then that vector quantity we can divide in two component. Cos component, horizontal one, जहाँ एंगल बनाएगा वहाँ कौन सा कंपोनेंट आएगा? cos, और उसके परपेंडिकुलर कौन सा आ जाएगा? sin. Clear? So we can divide it in two component, d cos theta and d sin theta. Now come to the derivation. If you will take that small element lower side, अगर आप small element यहाँ ले और dl length, dq charge, then this distance will be r only. Then from this, let the distance is how much here? This is also r. Let we consider this is also r. So that time the field will be in this direction. मैं अगर dl हम यहाँ ना लेके कहाँ ले? यहाँ ले, तो ये बाहर को ऐसा आएगा, away from it, outside. In that case, let it make an angle how much? Theta. तो कितने कंपोनेंट होंगे? दो. d cos theta, de sin theta. Yes or no? That means for upper half portion, ऊपर के पोर्शन के कारण d sin theta is coming downward. Due to lower half portion, d sin theta is coming upward. देखिए ऊपर वाले पार्ट के कारण d sin theta नीचे को और नीचे वाले पार्ट के कारण ऊपर को, लेकिन cos theta दोनों केस में कहाँ आ रहा है? सेम डायरेक्शन. That means we can write here d sin theta will cancel. Yes or no? These two will cancel to each other. दोनों क्या कर देंगे? Cancel. Total will be 0. So due to vertical component, field is 0. So total field at P is due to किसके कारण होगा? केवल DE cos theta के कारण. किसके कारण होगा? DE cos theta. Why sir cos theta? Because sin theta component will equal and opposite, they will cancel out, and cos theta components are coming in same direction. So total field, what will be total field? Total field E will be, for closed loop, integration of DE cos theta. Why sir? Integration, see, one piece dl, many pieces, many small pieces will be there in this ring. So their sum will be not only two pieces, दो ही नहीं, दो थोड़ा है, तो हमने लिए for example to show that these two will cancel out. Many pieces will be there. So for that you will integrate. सबके कारण क्या कर देंगे? Integration. Now put the value E equal to integration of closed loop DE 1 upon 4 pi epsilon naught dq upon r square cos theta. Clear? Now come here. If this angle is theta, so this angle is also theta, equal and opposite. These two angles are equal and opposite. If this one is theta, this one is also theta. From diagram cos theta. Now see, this is a triangle. दिख रहा है? In this triangle, if you see this triangle, if we consider this point A, OAP, triangle OAP, cos theta होता है base upon hypotenuse. Cos theta हो गया base हो गया x, hypotenuse is r. So base upon hypotenuse. Cos theta is called base upon hypotenuse. Hypotenuse is r. So equal to कितना हो गया 1/4 pi epsilon naught dq upon r square into x upon r. Now take the common. 1/4 pi epsilon naught is common. x बाहर आ जाएगा r cube square into integration only of dq. जिसके आगे डी होगा उसी का तो इंटीग्रेशन करेंगे, बाकी सब कांस्टेंट देखिए 1/4 pi epsilon कांस्टेंट टर्म, x is constant because distance and r is also constant. This is also distance. Now from triangle OAP, if you will find out small r square is capital R square plus x square. Why? Hypotenuse square is sum of perpendicular plus base. So r इक्वल टू हो गया अंडर रूट आर स्क्वायर प्लस एक्स स्क्वायर. अंडर रूट को क्या लिखते हैं? आर स्क्वायर प्लस एक्स स्क्वायर की पावर 1/2. अंडर रूट मीन्स 1/2. सो ई कितना आ जाएगा? ई इक्वल टू 1/4 पाई एप्सिलॉन नॉट एक्स अपॉन आर स्क्वायर प्लस एक्स स्क्वायर की पावर क्यूब है 1/2 है इंटू तो 3/2 dq मीन्स टोटल चार्ज. Total charge is how much? Total charge of the ring is q. So this is the answer. E equal to this 1/4 pi epsilon naught. We can write k x cube upon r square plus x square की power 3/2. This is the electric field due to a ring at its axis point without using Gauss law. So this is very very important. It was in board exam last year on 5 marks. So very easy to find out the electric field due to board ring. First of all, you will take a small piece upper side, you will check, and then you will cover. Then you will take a lower side, then you will check, then you will make a component, then you will see which components are cancelled. Vertical, these two are cancelled. So remaining one is this one. So for whole group, you will integrate it. Values you will find out from triangle. This angle is theta, so this one is also theta because it is equilateral triangle. This angle is theta, this is also theta. So this is the answer. Electric field due to a uniformly charged ring at its axial point. Is it clear? Very very easy. This is the answer. Clear? Now, so now that means we can say the electric field due to ring at distance x is how much now? E equal to coming kqx upon r square plus x square to power 3/2. Here q is charge, x distance from center, yes or no, and r is radius. R is what? Radius of ring. R is the radius of ring. This is the answer. That means this is the electric field due to a ring at its axial point. Is it clear? Now there are different forms you will get in competitive exam. This derivation, different forms. What are that form? Let's see. कैसे निकालते हैं? There are many cases. Now, case number 1. If point is very far, means x greater than r. If the point P whose distance is x is very greater than r, means अगर वो रेडियस से बहुत बड़ा है, that means so r square will come to 0. r square कितना हो जाएगा? 0. अगर r जो r है वो बहुत छोटा है, very small कहेंगे इसे, किसके कंपेयर में, x के कंपेयर में अगर r बहुत छोटा है तो r स्क्वायर की वैल्यू क्या हो जाएगी 0। सो e कितना हो जाएगा, e हो जाएगा k q x अपॉन 0 प्लस एक्स स्क्वायर की पावर 3/2 कितना हो जाएगा k q x अपॉन एक्स स्क्वायर की पावर 3/2, 2 कैंसिल आउट, k q x अपॉन एक्स क्यूब कैंसिल, तो e इक्वल टू आ गया k q अपॉन एक्स स्क्वायर। यस और नो, दैट मींस वी कैन से e इनवर्सली डिपेंड ऑन एक्स स्क्वायर। यस, दिस इज द फार पॉइंट। फार मींस कौन सी कंडीशन हो गई, आउटसाइड द स्फीयर। कौन सी कंडीशन है, आउटसाइड द स्फीयर, और आउटसाइड द स्फीयर की जगह पर लिख सकते हैं आउटसाइड द रिंग। कहां हो गया, आउटसाइड द रिंग। दिस कंडीशन इज फॉर आउटसाइड द रिंग। कहां की कंडीशन है, आउटसाइड द रिंग। दैट मींस वी कैन से आउटसाइड द रिंग, outside the ring, if we draw the graph between E and X, then it will be curved like this because it is inversely depend on each other. Yes or no? Now, case number 2. If x equal to 0, x equal to 0 means at center of ring. अगर x ही 0 है तो कौन सी पोजीशन है, सेंटर है। अगर x 0 है इसका मतलब रिंग का कौन है, वो सेंटर है। x इज द डिस्टेंस फ्रॉम द सेंटर, तो अगर x 0 है तो इसका मतलब सेंटर है। सो e कितना होगा, e इक्वल टू होगा हाउ मच, याद रखेंगे k इंटू क्यू इंटू 0 अपॉन r स्क्वायर प्लस 0 3/2, दैट मीन्स होल इट कम टू 0। वी कैन से एट सेंटर इलेक्ट्रिक फील्ड इज 0। दैट मीन्स we can write at center of ring E equal to 0. There is no electric field at the center. Clear? Now, case number 3. If R is very, we can write if R is greater than X. अगर R बहुत बड़ा, R means radius distance से बहुत बड़ी है, so x square will come to 0. ये r greater than x means x is very small, 0 नहीं है, very small है। इसका मतलब क्या है, inside the ring। कौन सी कंडीशन है, inside the ring। Why sir? See, r is small than x is small than r, इसका मतलब रिंग से बाहर तो नहीं गया, and it is not 0 भी नहीं है, इसका मतलब कहाँ है, inside the ring। So e कितना होगा, e equal to, put it here, k q x upon r square plus 0 की पावर 3/2, it will come k q x upon r square की पावर 3/2, e will become k q x upon r cube. This is the electric field inside the ring. This is electric field inside the ring. Inside the ring, E directly depend on X. From here, see E directly depend on X. That means if we draw the graph between E and X, it will come a straight line. If we draw the graph between E and X, it will come a straight line for what? For the ring. Is it clear? So inside the ring, electric field is 0, and inside the ring, at the center electric field is 0. Inside the ring it is directly depend on x. Outside the ring it is inversely depend on x square. Here it will decrease. At the center it will be 0, and inside the ring it will be increase. Yes? Yes or no? Now, fourth case if we do, if x equal to r. X equal to r means at surface. X equal to r. X equal to r, that means at surface. So E, how much E will be, k q x upon r square. At the place of x also we have to put r square 3/2, k q x upon 2r square की पावर 3/2. So it will come E equal to k q x 2 की पावर 3 means 8 का रूट कितना होगा, 2√2 r cube. This is the answer at the surface. This is the value at the surface. Is it clear? This value is at surface, this value inside, this is at center, this is outside the center. This is the electric field due to a ring at different points. Now, next point what we will discuss. Now, if someone will ask us that what is the maximum value and at what point it's the maximum value. What is the maximum value of this electric field due to a ring and at what point its value will be maximum. That means what is the maximum value and at what condition its value will be maximum. Means the electric field produced by a ring will be maximum. Obviously it will be maximum, but at what point it will be maximum. Let's see. Suppose this was the ring, its center is O, radius we have taken R. Now our task to check at what point its value will be, its electric field due to this charge sphere, at what point electric field will be maximum. Inside the ring it will be maximum or outside the ring it will be. Let's see. For maximum electric field, for maximum electric field, dE upon dx should be 0. This is the condition for maximum. अगर वो मैक्सिमम वैल्यू है तो उसका डिफरेंशिएशन क्या हो जाना चाहिए? 0, बिकॉज मैक्सिमम वैल्यू पर पर्टिकुलर वैल्यू, ए फिक्स वैल्यू इज कॉल्ड मैक्सिमम वैल्यू एंड दैट टर्म विल रिमेन कांस्टेंट एंड डिफरेंशिएशन ऑफ कांस्टेंट इज ऑलवेज 0. इसका मतलब अगर मैक्सिमम है वहां पर तो डिफरेंशिएशन क्या होना चाहिए? 0. वाई सर? एट मैक्सिमम पॉइंट वैल्यू विल बी मैक्सिमम, आफ्टर दैट इट विल बी, इट शुड बी कांस्टेंट ना, कांस्टेंट हो जानी चाहिए. मतलब मैक्सिमम होगी, एक ही तो वैल्यू मैक्सिमम हो सकती है, तो इट विल बी कांस्टेंट. सो इट्स डिफरेंशिएशन विल कम टू 0. नाउ वी नो E कितना था? kqx अपॉन r स्क्वायर प्लस x स्क्वायर की पावर 3/2. वी विल पुट दिस वैल्यू हियर, इंप्लाई दैट d अपॉन dx kqx अपॉन r स्क्वायर प्लस x स्क्वायर की पावर 3/2 इक्वल टू 0. नाउ k is constant, बाहर आ जाएगा, q will not change, only those term we are differentiating with respect to x, so only x square, x term will be there, minus 3/2 equal to 0. we have taken it inside it. ऊपर ले गए तो कितना हो गया? माइनस हो गया. सॉल्व करेंगे. kq, there are two term, x is one term and r square plus x square is the second term. now differentiation of two terms कैसे करते हैं? फर्स्ट टर्म ऐसे रहेगा, डिफरेंशिएशन ऑफ सेकंड करेंगे, प्लस सेकंड ऐसे रहेगा, डिफरेंशिएशन ऑफ फर्स्ट करेंगे. इज इट क्लियर? इक्वल टू 0. कैसे करते हैं? फर्स्ट टर्म रिमेन सेम, डिफरेंशिएशन ऑफ सेकंड प्लस सेकंड टर्म डिफरेंशिएशन ऑफ फर्स्ट. नाउ यू स्टार्ट kq. फर्स्ट टर्म इज x, x will remain same. now differentiation of second, differentiation of this term d upon dx r स्क्वायर प्लस x स्क्वायर की पावर माइनस 3/2 प्लस सेकेंड टर्म r स्क्वायर प्लस x स्क्वायर की पावर माइनस 3/2 डिफरेंशिएशन ऑफ फर्स्ट x इक्वल टू 0. नाउ सॉल्व इट. kq, x विल रिमेन सेम, डिफरेंशिएशन कैसे करते हैं? पावर आगे मल्टीप्लाई करते हैं, 3/2 r स्क्वायर प्लस x स्क्वायर, पावर में से कम कर देंगे, -1 इनटू इनसाइड इसके अंदर करेंगे, r इज कांस्टेंट तो उसका डिफरेंशिएशन 0 प्लस x का 2x. इन द रिस्पेक्ट ऑफ x वी आर डूइंग, सो x का क्या हो जाएगा? x स्क्वायर का डिफरेंशिएशन 2x प्लस r स्क्वायर प्लस x स्क्वायर की पावर माइनस 3/2 विल रिमेन सेम. dx ऑफ dx कितना हो गया? 1 इक्वल टू 0. नाउ फ्रॉम हियर इसको राइट में लेके तो कितना हो जाएगा? यहां सॉल्व कर लेंगे. x इंटू माइनस 3/2 r स्क्वायर प्लस x स्क्वायर की पावर माइनस 5/2. 2 इज एलसीएम, 2 यहाँ मल्टीप्लाई, माइनस 3 माइनस 2 माइनस 5 प्लस इंटू 2x इंटू 2x आ जाएगा. r स्क्वायर प्लस x स्क्वायर की पावर माइनस 3/2 इक्वल टू 0. सॉल्व कर लेंगे. 0 हो गया. k अपॉन q, kq यहाँ आएगा तो kq से डिवाइड करेंगे, 0 हो जाएगा. कितना आएगा? 2 से 2 कैंसिल आउट, माइनस 3x स्क्वायर नीचे ले आएंगे, r स्क्वायर प्लस x स्क्वायर की पावर प्लस 5/2 ऊपर से कहाँ ले आए? नीचे, इक्वल टू, इसको राइट में ले चलिए, माइनस r स्क्वायर प्लस x स्क्वायर की पावर -3/2 राइट साइड ले गए क्योंकि 0 हो गया इक्वल टू 0 आ जाएगा। चलिए सॉल्व करिए। तो आगे सॉल्व करेंगे तो -3x² अपॉन r² प्लस x² की पावर 5/2 इक्वल टू -1 अपॉन r² प्लस x² की पावर 3/2। -3/2 3/2 दिस इज कैंसिल आउट, सो माइनस माइनस कैंसिल आउट। 3x² अपॉन क्या बचा r² प्लस x² इक्वल टू 1। ठीक है 5/2 माइनस 3/2 कितना बचा 2/2। 2/2 मीन्स 1, सो ओनली 1 टर्म विल रिमेन। So क्रॉस मल्टीप्लाई 3x² इक्वल टू r² प्लस x², लेफ्ट में जाएगा 3x² माइनस x² इक्वल टू r², 2x² इक्वल टू r², x² इक्वल टू r²/2, x इक्वल टू प्लस माइनस r/√2। So that means there are two values. How many values are coming? X have two values. One x equal to plus r/√2. Second x equal to minus r/√2. That means at these 2 points value will be maximum. Very very important for competitive exam. For ring at 2 points, one plus x equal to r/√2 and one x equal to minus r/2. The value will be maximum. Meaning, what is the meaning of it? देखिए क्या मतलब है इसका, देखिए आंसर। Suppose this is the ring. Center is O. Radius we have taken r. So one point will be this side, x equal to plus r/2 √2. One point this side, x equal to minus r/√2 from center. At these 2 points the value will be maximum. इन 2 पॉइंट वैल्यू क्या होगी maximum. That means now if we draw the graph between E and X, then which type of curve we'll get? कैसा कर्व मिलेगा? देखिए at center E is 0, x 0 तो E also 0. Inside it, its value will increase and reach to maximum. At what point it will maximum? When x equal to plus r/√2. Then after its value start decreasing. And the decreasing case is x E inversely depend, E directly depend on x for inside, E 0 for center, E inversely depend 1 upon x². In previous data we have discussed x², so divide. Now similarly negative direction also, one point is minus also. So inside at the center 0, inside increase then maximum. At what point it will maximum? Minus r/√2. After that its value start decreasing. This is the graph for, this is the graph for, तो मोड़ सही बना लेंगे, this is the graph for a ring. So at these 2 points the value will be maximum for a ring where electric field is maximum. So this ring is very very important. Last in 2019 it was in board exam also, for 5 marks question was there in board exam. Now चलिए अब बात करते हैं अगला इंपोर्टेंट पॉइंट्स क्या है। चलिए अगला है, मान लीजिए आपके पास रिंग है ही नहीं, आपके पास जो है कंप्लीट चार्ज रिंग नहीं है, आपके पास है, सपोज आपने निकालना है इलेक्ट्रिक फील्ड ड्यू टू चार्ज हाउ यूनिफॉर्मली, दिस ऑल डेरिवेशंस आर फॉर यूनिफॉर्मली चार्ज आर्क, uniform to charged arc. Electric field due to charge uniformly charged arc. Arc means everybody know what is arc. क्या होता है? A curved loop, a curved loop or curved momentum, that is called arc. इसे क्या कहते हैं? arc. खींचे अपने arc खींचते हैं ना, so that curved path is called arc. Now what is our task? Our task is to find out electric field due to uniformly charged arc. Means we don't know what is the length of that arc. It is not a complete loop. It is a small piece of that loop. So how we find out? So say, suppose we have an arc. Let this is an arc. This arc is A, B. This is an arc. Clear? And the charge is distributed uniformly on this arc. So the charge given to this arc uniformly. The charge is distributed on its curved length. That is charge density plus lambda. Charge density is what? Plus lambda. And there is the center of this arc. The radius of this arc is how much? from this center O, the radius of arc is R, capital R. This is the radius of arc. So for that, you first of all consider, what you consider? Let us consider an arc of charge density lambda and radius capital R. This is a arc. Now due to this arc, our task is to find out electric field at the center of this arc. इस point पर जहाँ पर से बनता है वहाँ पर electric field निकालना. So what you will do? First of all, we will take, let this make an angle. This angle is how much? This angle, suppose alpha. How much? Alpha. We will take its center point. Like suppose this is the center point of this arc, M. Midpoint of this arc is M. Clear? So this, suppose this is the midpoint. Midpoint ले लेंगे, बना सकते हैं सीधा midpoint. If this is midpoint, upper angle will be, this angle will be alpha by 2 positive, and this angle will be minus alpha by 2. Why minus alpha? Everybody know in a circle, if you move in a circle, then above the circle, anti-clockwise positive, downward negative. So above this line positive, below this line angle is negative. Now, our task to find out the electric field due to this arc. For that, what we will do, we will take a small piece of this arc. Let's take a small piece of this arc of length dl. So here we will let us consider a small element dl of charge dq. Let its charge is dq. Now, suppose the lower part of this dl, इस dl का lower part कैसे करते देखिए. Suppose the lower part of this dl make an angle how much? Theta, and the upper and lower part difference for this is small. This is small length, so angle is also very small, d theta. Clear? Now we will find out electric field due to a small element dl at center O. कितना होगा? DE होगा 1/4 pi epsilon naught dq upon r square. Radius will remain same, r. So here the distance due to this, it will be r square. Now d, this 1/4 pi epsilon, we can write k dq upon r square. Clear? This is the electric field due to a small element. Now we know charge density lambda equal to charge upon length. That means per unit length charge density is 1 मीटर में कितना चार्ज है? In 1 meter charge is how much? Lambda. Charge density is called charge in 1 meter. Charge per unit length means charge in 1 meter. How much? Lambda is given. So dq is the charge of dl. So its charge will be lambda dl. So dq equal to lambda dl. See, in 1 meter charge is lambda. Charge density किसे कहते हैं? Charge in 1 meter unit length पर जितना charge है, that is called charge density. Charge density is given lambda. That means in 1 meter charge is lambda. So in dl meter charge is lambda dl. भाई देखो, 1 मीटर पर q है, 2 मीटर पर q प्लस q 2q, 3 मीटर पर 3q, ऐसे लैम्डा l मीटर पर dl मीटर पर लैम्डा dl. सो d कितना हो जाएगा? k लैम्डा dl अपॉन r स्क्वायर. k लैम्डा dl अपॉन r स्क्वायर. नाउ वी नो एंगल इक्वल टू arc upon radius. Angle equal to arc upon radius. Now for this arc, only for dl, what is the angle for dl? This angle is d theta. Length arc is dl, radius is r, so dl will become r d theta. Dl will be how much? R d theta. This we know about. This is plane angle, class 11 plane angle. So now here dE will be k lambda into r d theta upon r square. This is cancel out, k lambda d theta upon r. Is it clear? This is the electric field due to a small element. Right? Now, this is this type of element, positive charge. Due to positive charge, electric field is outward. Electric field is outward. Everybody know. Due to positive charge, electric field is always outward. So at this point O, this electric field will be outward. Let it make an angle. How much? It make an angle theta. To make an angle theta. This is theta. So these are the equal and opposite. इसके द्वारा बना हुआ है. So this is also theta because this is very small ना. So इससे बना हुआ एंगल में क्या आएगा? Theta. Now we can divide in D two component. DE cos theta and vertical one DE sin theta. Right? So DE is at angle theta. DE किस एंगल पर है? Theta पर. So we can divide DE in two component. D cos theta horizontal one and D sin theta vertical. Now if we will take this small element here, अगर हम इस स्मॉल एलिमेंट को यहाँ लेते हैं, so the d theta will come like this. In that case, this is theta. This is above component d sin theta and horizontal component d cos theta. अगर मैं dl यहाँ ले लेके यहाँ लेता, in that case it will come like this. Yes or no? So which component will be cancelled out? These two are cancelled out. So total field is how much? Due to only d cos theta. Total field is integration of dE cos theta. Only which component? D cos. Sir, why integration? Many small pieces will be there. 1, 2, I have considered 3. Like this, we can divide it many small pieces. So integration of all this off. So now integration. Then d is k lambda dq upon d theta. K lambda. Now this is coming d theta upon r into cos theta. Now here the differentiation, the integration is of theta. किसका integration होना है? Theta का. Theta is what? पूरे लूप के लिए निकाले तो theta is minus alpha by 2 to plus alpha by 2. See, minus alpha by 2 से कहाँ तक जा रहे हैं? Plus alpha. For this whole loop, angle will be minus alpha by 2 to plus alpha by 2. So now we will integrate it. What we will get? K lambda upon r is constant. Integration of cos theta is sin theta. Angle alpha by 2 plus alpha by 2. So how we will solve it? K lambda upon r. First we will put upper value. Sin alpha by 2 minus sin minus alpha by 2. Clear? So it will come equal to K lambda upon r sin alpha by 2 plus sin alpha by 2. Why? We know sin minus theta equal to minus sin theta. Everybody know theta minus पे तो बाहर आ सकता है, तो माइनस बाहर आएगा, माइनस माइनस प्लस. So it will come equal to k lambda by r 2 sin alpha by 2. This is the electric field due to an arc. This is the electric field due to an arc. This is the angle formed by arc at its center. Lambda is charge density, r is its radius, and alpha is the angle formed by it at its center. Right? This is the next one. Very, very important for the board. Suppose the question is there. This is an arc, semicircular arc of charge plus. This is very important question for competitive exam. Yeah, IIT के बार आएगा. Here at point O, it's a radius we are taking R. Now our task, find electric field at O. Question is that point electric field at O. Find electric field at O. Now here we are tasked to find out electric field. I have told you, due to arc electric field, now very easy. We know you have to keep E equal to k lambda by r 2 sine alpha by 2. We can write it 2k lambda by r sine alpha by 2. Now alpha is the angle form. Here the alpha is how much? This is the alpha. And the angle form on the line due to this arc, what angle will form? 180 degree. So put it here, equal to 2k lambda upon r sine 180 by 2. Sine 180 is 90. So 2k lambda upon r sine 90 is 1. This is the answer. This option will be correct. This is very important for the competition. Now you can find out the electric field within a minute. This will be very easy now for you. Very easy. Suppose the question is not like this. Question यही है. Question उसने पूछ दिया कि find the electric field due to an arc. This is the arc. And now the condition is given here. This is the condition. Now the condition is given. What condition? Same question. Now the charge this side are negative. And this side positive. The charge this side is positive, this side is negative. Now what we will do? क्या करेंगे? अब क्या करेंगे? Very easy. How many electric field will be there? One side positive, one side negative. इसके लिए so we will check it first of all. For one side इस प्लस के लिए पहले इस प्लस का निकालते हैं. इसको एक मान लेते हैं. ये एंगल कितना मानते हैं? This is suppose whole angle is now alpha. This whole angle is alpha. So due to plus side even how much? 2k lambda upon r sine alpha by 2. Sine alpha. This angle is 90. Alpha by 2. That means 2k lambda. And now this side is 90, that side 90. Total 180. R sine 90 sine 45. So it will come 2k lambda upon r sine 45 1 upon root 2. This is cancelled out. What you will get? Root 2 k lambda upon r. Yes. Now this is which side? Positive. Due to positive electric field will be outward even. So here we will write outward. This is due to plus. Now we will find out electric field due to minus side. Due to minus side, what will be the electric field due to minus side? क्या होगा minus side का electric field? Now see, it will be same equal to 2k lambda upon r sine alpha by 2. That means equal to 2k lambda upon r sine alpha is again 90 by 2. This side is also 90. ये इसके लिए भी 90 है. 2k lambda by r sine 45. Sine 45 is 1 by root 2. 90 means 45. 1 by root 2. So it will cancel out. Root 2 k lambda upon r. This will be negative inward. Inwards means this is the side. So the electric field will be inward E2. Right? Now this side and this side. This is midpoint. हम midpoint अगर इससे लेते हैं, ये कितना आ गया? 90 आया. 45 ये 45 हो गया. बीच का ये 45 डिग्री, ये भी 45 डिग्री, ये 45 तो ये भी 45 डिग्री, ये 45 तो ये भी कितना होगा? 45 डिग्री. एंगल अगर सेम लें, अगर ये दोनों कितने पे होंगे? 90 डिग्री पे होंगे. These two are also 90 degree. Now E1 and E2 are at 90 degree. इसके कारण इलेक्ट्रिक फील्ड और इसके कारण इलेक्ट्रिक फील्ड कितने एंगल्स में होंगे? 90 के. ये दोनों 90 पे है, तो इनका इलेक्ट्रिक फील्ड कितने एंगल्स पे होगा? 90 के एंगल पर होगा. कितना आ जाएगा? ये E होगा E1 स्क्वायर प्लस E2 स्क्वायर प्लस 2E1 E2 cos थीटा. The resultant of two vectors will pass from their center only by parallelogram of vector addition. So E square equal to E1 and E2 are same. E1 square plus E1 square plus 2 E1 cos 90 is 0. So E1 is 2E1 square. Both are same. कितना आएगा? E equal to root 2 E1. E equal to root 2 E1 is root 2 k lambda upon r. Root 2 2k lambda upon r. This is the answer. Clear? This is the answer. This type of questions you will get. Many questions are there in competitive exam. Whenever you will go for quota and for the coaching, there you will get these all. This topic is there only. The teacher will taught you. This is very easy and very important. So I hope that you have learned something from it, and I hope that you have learned something from today video. So फिर मिलूंगा एक नई थॉट, एक नए वीडियो के साथ और कुछ नए क्वेश्चंस के साथ. इन टॉपिक को क्वेश्चन किस तरह के आते हैं और कैसे कॉम्पिटिटिव एग्जाम्स में आते हैं, देन वी विल डिस्कस. तब तक के लिए बाय. चलिए अगला पॉइंट डिस्कस करते हैं. क्या है अगला पॉइंट? अगला पॉइंट डिस्कस करेंगे. हमें निकालना होता है क्या? इलेक्ट्रिक फील्ड ड्यू टू यूनिफॉर्मली चार्ज्ड वायर. Due to uniformly charged wire. This is a task without Gauss law. Without Gauss law. Now this is very important. This is generalized equations for a wire. This is a general equation. By this derivation, after this derivation, you can solve any question from related to wire. So what is our task? Our task to find out electric field due to an uniformly charged wire. For that, what we will do? First of all, we will consider a wire. Suppose this is a wire. We are going to consider a wire. Suppose this is a wire, and this wire is uniformly charged. This wire is uniformly charged. Let its charge density plus lambda. So what we will do? We will write here. Let us consider a wire of charge density plus lambda. Then from the midpoint of this wire, we are going to take a point P at a distance capital R from it. Suppose there is a point. At this point our task to find out electric field. इस point पर मेरा काम है, इससे एक point ले लिया मैंने P at distance capital R. Here is my task to find out electric field. अब given क्या होता है देखिए. In the derivation you will get these two angles. The angle formed by topmost is theta 2 and the angle formed by the lower part is theta 1. Like it may be any angle, कोई भी angle हो सकता है. Now our task to find out due to this wire at this point electric field. So what we will do? We will take a small element of this wire. This is. Suppose we are taking a small element of this wire. This is the small element we are taking. It is dx. How much? Dx, and at distance from the center x. At a distance x. So this we will write. Let us consider a small element dx of charge dq. Of charge dq. Now dq will be how much? dq होगा lambda dx. Why sir? Charge density is lambda, means charge per unit length. 1 unit length. Charge in 1 meter. Charge density means linear charge density means charge per unit length. Means in 1 meter charge is lambda. So how much meter dx? So in dx charge will be lambda dx. Is it clear? Now let its lower end make an angle at this point is theta, and the angle between the lower and upper end is how much? This is small, due to that reason this angle we are taking d theta. The angle formed by, see, this is dx, this is dx, and this is point P. Suppose this is point P. This is going to make an angle how much? Theta, and the lower and upper ends are making an angle d theta. Is that clear? This we have considered. Now we'll move further. We'll write now here electric field at P due to small element dl, how much d equal to 1 upon 4 pi epsilon naught dq upon r square. Let this distance, we are going to consider this distance, we are taking how much? Small r. How much we are taking? Small r. So this is very small, so this length is approximately negligible, we can neglect. So at far point, these 2 points will be same. So this distance we have taken r. So this is the electric field. Now 1 upon 4 pi epsilon we can write k. K equal to dq. This will be dq upon r square. dq upon r square. This is equation 1. This is the electric field at point P due to small element. Now from triangle, if you see this point we are taking O, this is A. This upper point I am going to take this point A. This is OAP. OAP. Now this is hypotenuse, base and perpendicular. So small r square will be capital R square plus x square. Why, sir? See here. This is x. This distance is r, and this one we have taken a small r. So how much after this? This is hypotenuse r square x square plus this one. So r will become under root r square plus x square. Is it clear? Now put this value here. So dq is how much? dq is lambda dx. dq is, this is, we can take 1 lambda dx upon under root r square plus x square का whole square. r square plus under root r square plus x square का whole square I think. So it will come k lambda dx upon r square plus x square. This is equation number B. Correct? So this is electric field due to a small element dx at a distance r. Now everybody know about it. Angle equal to arc upon radius. Yes, angle equal to arc upon radius. Now angle equal to arc upon radius, we can put this value. Now we are not here, we are taking simple thing. One thing we will do, we will not take this form. I am not solving this now according to the book. Now from here I am not solving according to the book. I am giving you a new method. It will satisfy. Now see how you will solve after this. After this, how you will solve? You see, from this triangle, this angle is how much? Theta. This angle is theta. If I will find out from triangle OAP, from this triangle, we will find out tan theta. Tan theta will be perpendicular upon base. Perpendicular is x, upon base is r. So from here you can write x equal to r tan theta. Yes or no? X equal to r tan theta. Put this value. Putting value at B. Putting value at B. So we will get, so dE equal to k lambda. This is r square plus r square tan square theta at the place of x. Now if we differentiate, dx will be r integration of d theta. Integration of tan theta is sec square theta d theta. So dx will be, you will differentiate, x is coming r tan theta. If you will differentiate it, dx equal to r is constant r. Tan differentiation of tan is how much? Sec square theta into d theta. Integration d upon dx of tan theta. d upon d theta equal to कितना होगा? Sec square theta. So differentiation of tan theta is how much? Sec square theta. So here at the place of dx, we will put r sec square theta d theta. R sec square theta d theta. This is the formula. Now we'll further solve it. What we'll get? dE equal to, this will be dE equal to, now from here कितना आ जाएगा? d equal to k lambda upon r square is common, 1 plus tan square theta r sec square theta d theta. This power is cancelled out. So we will get from here k lambda upon r 1 plus tan square theta, everybody know 1 plus tan square theta equal to sec square theta. Yes or no? 1 plus tan square theta is equal to sec square theta. कितना होता है? Sec square theta होता है. So it will come how much? Sec square theta upon sec square theta d theta. This is cancel out. It will become k lambda upon r d theta. This is the electric field due to a small element at point P. After solving all the conditions, this is the final value of electric field at point P. Is that clear? Now, this small element is which type of charge? It is positively charged, and due to plus charge, electric field is outward. That means at this point the electric field will be outward dE. So how much angle it will form? The inner angle we have taken theta, so the lower angle is also just opposite theta. So how many components we can do? We can take two components, dE cos theta, and the vertical one is dE sin theta. d cos theta and d sin theta. d cos theta and d cos theta in x-axis and d sin theta in y-axis. So number first, for x-axis ex कितना होगा? de cos theta now equal to how much? k lambda upon r cos theta d theta. Is it clear? Now total field due to whole wire in x-axis, what will be the total field? Ex total, how much? Integration we will take cos theta d theta. This wire is moving from in angle theta 1 to theta 2. Theta 2 is below of this, so we will write minus theta 1 to plus theta 2. I have told you lower one minus upper one plus. Is it clear? कितना आ जाएगा? This will be minus theta 1 to theta 2. So we will integrate now. Integrate it. Here I am solving. After this, you come at here. Ex equal to k lambda upon r is the constant. K lambda upon r is constant. Integration minus theta 1 to plus theta 2 cos theta d theta. Now we can solve it. K lambda upon r. Integration of cos is sin theta. Sin theta minus theta 1 to theta 2. Now you will solve it. K lambda upon r, first upper value, sin at the place of theta upper value, sin theta 2 minus sin minus theta 1. Yes, now solve this. K lambda upon r, it will come sin theta 2 plus sin theta 1. This is the answer. This is the electric field at x-axis. In which axis? X-axis at point. This is very important. Now this theta can be vary. Different values will be there. After this we will solve the numerical. Then let's see the values are different. Theta 1 plus, so it is coming k lambda, k is 1 upon 4 pi epsilon naught, k lambda upon r, sin theta 2 plus sin theta 1. This is the electric field in x-axis. In which axis? X-axis. At this point. Right? In x-axis. Now one field is in y-axis also. Now we will check what will be the value in y-axis. What will be the value in y-axis. Now we will go for y-axis. किसके लिए चलेंगे? Y-axis के लिए चलेंगे. चलिए. From here we can rough. Till this it will remain same, for all the data will remain till this point same. So now from here we will cancel. We will rough this all. Now. Chलिए. Observe. Now we will move from this point. Now. Chलिए. So if we will do for which axis? For y-axis. Which axis? Y-axis. For y-axis, Ey, how much? Ey is dE sin theta. D is how much? K lambda upon r sin theta d theta. Yes or no? Sin theta d theta. Because d is this one, sin theta d theta. Total field Ey total. What you will do? Integrate k lambda upon r sin theta t theta. Theta will be minus theta 1 2 plus theta 2. So when you will integrate, dy will be k lambda upon r is constant. Now integration of sin theta minus cos theta. Integration of sin theta is cos theta minus में theta 1 to theta 2. Then put the upper value number first, k lambda upon r. It will become cos minus at the place of theta first upper value theta 2 minus then lower value minus. This minus is for formula, one minus is already there. You can take this minus in front. अगर आप इस minus को front पर ले लेंगे तो यहाँ प्लस ही लगाएंगे आप. cos theta 2 cos minus theta 1, right? cos theta 2 minus cos theta 1. Now everybody know what you can do. क्या कर सकते हैं? cos जैसे आपको पता है sin minus theta equal to sin minus sin theta. cos minus theta equal to cos theta. This is the formula. cos minus theta हमेशा क्या होता है? cos theta. E lambda equal to minus k lambda upon r cos theta 2 minus cos theta 1. हम माइनस लिख सकते हैं इसको बिकॉज cos माइनस थीटा भी कितना होता है? cos थीटा होता है. नाउ साइन को अंदर भेज देंगे तो क्या आ जाएगा? E y equal to k lambda upon r. This minus will take inside. So cos theta 1 minus cos theta 2. This is the answer for y-axis. This is the electric field for y-axis. So for whole wire we have derived the equation in x-axis as well as in y-axis. So this is a different method which I am going to explain. You will not get any books with this method. So this is very easy. Easily we can you will get the answer. Now few students are confused that in that this is x. This length, well, this is very small. You can neglect it. This is very small. From far distance, when you will observe it, this distance will not visible. Counting में नहीं आएगा at far distance. It is very small. So this is very important derivation for your syllabus. This is very important for the board exam as well as for your competitive exam. Let's see few questions relative to this topic. Chलिए. This board is not today is not clinic this. Oh, now few numerical. This is very important for the board. Check. Now we will solve few numericals related to this topic. Few numericals which are related to this topic. We will take few numericals. Now, for example, which type of numericals you will get in competitive exam? Number first. For example, the numericals there. You have given a wire. This is a wire, a charge density plus lambda. Suppose this is a wire, and the point is at a distance r here from here. Is it clear? Now, what will be the how we will solve it? अब कैसे इसे solve करेंगे? See, this is very easy part. बहुत आसान है. Now sir, how we will solve? कैसे solve करेंगे? At this point, it is coming how much? Theta 1, this angle is coming 0. From here this angle will come to how much? यहाँ से कितना आएगा एंगल? ये एंगल कितना होगा? देखिए, from there let this angle is going to form how much? Theta 2. Now theta 1 is 0 because it is in the line of this end only. So here the angle will be theta. So Ex will be how much? Ex होगा k lambda upon r. K lambda upon r sin theta 1 plus sin theta 2. So what will be k lambda upon r sin 0 plus sin theta 2. Sin 0 plus sin theta 2. It will become k lambda upon r sin 0 is 0 plus sin theta 2. So it will come k lambda upon r sin theta 2. Yes, sin theta 2. Clear?